Hello everyone, in this video what we're going to do is we're going to have a look at pointers. Now pointers, the concept of pointers are in some low level languages like I think Rust has it, I think C definitely does have it, and you have a couple of other low level languages. You wouldn't really find a pointer in a high level language like say Python. I mean the most common modern day high level language is Python. I don't think you'd find it in JavaScript either, but you will 100% find it in C, C++, and maybe even Rust, which are low level languages. Now what a pointer essentially is that it's actually like a variable that points to a memory location. So assume I have an int x and I make it equal to 9, right? Now int x is the name of a memory location, right? And each memory location on your computer has an address, okay, and that address is stored as a hexadecimal value. Okay, so if I were to come in and I would say cout x, obviously it's going to be 9. And if I want to print out the address of this, then you use a special operator called an ampersand to print out the memory address. Alright, now if I do that, you can see this is the memory address in hexadecimal, 0xf and whatever that is. Alright, this funny looking so that's the memory address, okay, or the location where the variable is stored. Now why is that really important? Why do we use pointers in real life? Well, there's many applications on the low level edge. It's actually it's also used in hacking. Alright, if you want to maybe change the value that is stored at that variable, or at that location, then you use a you can adjust it. You can access values stored at a certain location or at a certain address. You can dereference them, stuff like that. So that's what we're going to have a look at now. This is how you print out the address, but just leave this for now. In order to actually declare a variable which is a pointer, okay, do you see the one where we said and x? This isn't really a pointer, it's actually a memory address. The way to declare or make a pointer would be just like a normal variable, an int. Okay, if you want to store a pointer to an integer value, okay, so the way to do it is put an asterisk like that. Now x is a pointer. Alright, x is definitely a pointer now, but it's an empty pointer, so we don't have a value for x. If I were to cout x like that now, then you can see it has this value, no address essentially yet. But by the way, whenever you want to access the value, okay, never mind, I'm going to tell that later. Okay, so assume I have a variable called b. I make it 88. Now I want to point to b, and I make x the pointer to b. The way to do this would be like this: b, but you have to pass in the location using the ampersand. And now if I were to run the program, you would see that it actually prints out the memory location of b. Now x is actually a variable that is pointing to b. This, by the way, is not, x isn't 88. Alright, this is something I have to clarify. X is not equal to 88. However, x points to 88. So whenever I want to access x, okay, so if I say for example x plus 1 would never be 89. However, what x plus 1 would be is x plus 1 would refer to the next memory location inside memory. Okay, I'm going to show you when we use arrays, but for now let me just show you the concept of dereferencing. Okay, so this is how you declare a pointer, and whenever you want to access x, you are going to use x. You're never ever going to do this. Alright, when you want to, however, check the value of x, okay, x is a memory location. So if you want to know what value is stored inside of the memory location that x points to, then you're going to use the asterisk again, and this is what is called dereferencing. Okay, this concept where you put an asterisk besides that, alright, you dereference x. Here you referencing, here you dereferencing. Okay, so if you can see, x points to the variable b, and now it returns the value at b. So this is just simple. That's just what pointers are essentially. There's nothing much other than that. I want to actually show you the applications of pointers in arrays. Okay, so when you have an array, I'm going to create an array right now, int a rr, alright, and I'm going to say maybe an array of 5 and 5, only 5. Now I'm going to equal it to, like, I'm going to say 1 2 3 4. I'm going to store 5 elements inside of it, and I'm going to erase everything else. Okay, so just focus on the array. Now we have an array of 5, right? Now what I'm going to do is I'm going to create a pointer called x again, or let's call it p this time. Okay, now p is a variable. Once I put a asterisk behind it, then it's a pointer. Now once that's done, I want to actually make it equal to array. Now please take note that when you are assigning an array to a pointer, you don't put the @ sign, because if I were to go ahead and let me just show you real quick, if I were to see out array, okay, the variable, usually what you would do is you would do that, right? You'd have an index position, but say we don't have an index position, we just see out the array and I run the program. You can see it prints out the memory location. Okay, so what this prints out is the first. Okay, it's going to print out the first index's memory location. Excuse my spelling. Memory location. Okay, this prints out the first index's memory location. For that reason, if I create a pointer called p, I'm not going to say ampersand. I'm not going to say that. I'm going to rather just say ARR, because it's, of course, it is a memory location. ARR represents a memory location. So now p just points to it. Now as I said before, that if you say p plus 1, it would not say that, go to the first one and add 1 to it. It's not going to say that. It's not the first value, the first element in the array is not going to be a 2. However, what this would do is, let me just demonstrate. I'm going to say cout p plus 1. Okay, and of course, if I were to see out this, then it's gonna show the memory address. It's gonna print out the memory address. Oh, by the way, I forgot to actually, do that. Comment that out so it doesn't run. Now it prints out a memory address, but we want to know what is stored at that memory address. So p plus 1. As you know, we can dereference. So now this is 1. Okay, so now you can see that if I say p, it represents the first memory location in the array, and if I do that, dereference p, it's going to show me the first one. So you can actually see that if we do r, ARR represents the first element. However, if I were to say plus, okay, so p plus 1, and now I put brackets around it because I want to say p plus 1, and that's going to give me a memory address, and I want to dereference that memory address. So what this is going to do is it's going to say p plus 1, and it's going to go to the next memory address. It gives us a 2. How does that work? Look, p refers to the first memory location, the first index where 1 is located, and an array is consecutive memory locations that are named. So on your computer you have RAM, right? And on this RAM you have like a box or a memory location where you store data. Now they have names. Actually they don't have names, they have like addresses, but you give them a name called ARR. okay, or int x, int, like using variables. But if you want collective or consecutive memory locations that are placed one after the other, then you give an array. You call them an array essentially. So this is an array. P plus 1 would be the same memory address, but you just go to the next one, P plus 1, and then you dereference that next memory address. So it's going to go to the first memory address, which is 1. It's going to go to the second memory address, which will return a hexadecimal value, and it's going to dereference that one, so it's 2. And of course we can go plus 2 plus 3, and it's going to keep us giving the next elements in the array. So that's what pointers do essentially. Pointers will point to memory locations. So plus 3, P plus 3 would mean the first element plus 1, 2, 3. So it gives us 4. So that's what it is.